So good morning once again. In our previous class of trigonometry, we covered, so in trigonometry, we covered on compound angles, and then in these compound angles, we stated the compound angle for cos. We said, number one, sine A plus or minus B is equals to sine A cos B plus or minus sine B cos A. And also number two, we said we have cos A plus or minus B is equals to cos A cos B minus or plus sin A sin B. And also again, you were able to prove number three, that tan A plus or minus B is equals to tan A plus or minus tan B, and all this over 1 minus or plus tan A tan B. So I wanted today we start by an example on these compound angles formulas. And our example, we go like this. Our example is sine alpha is equals to 5/13, and sine beta is equals to 40/41. So find without using, find without using calculator or tables. Roman 1 as cos. Roman 1, we have sine alpha minus beta. Roman 2, we have cos alpha minus beta. Roman 3, we have sine alpha plus beta. Roman 4, we have tan alpha minus beta. Roman 5, we have cos alpha plus beta. Roman 6, we have tan alpha plus beta. Now, in this our solution, I will pursue to do the I'll do sine alpha minus beta, and also cos alpha minus beta. Then you will be able to try the rest 4 using the same method. So let us go to the solution. So, so clearly, we have said that the compound angle formula, that is sine A plus or minus B, is simply equal to sine A cos B plus or minus sin A sin B cos A. We also have cos A plus or minus B is equals to cos A cos B minus or plus sin A sin B. Now, I know maybe you can also put for tan, as you have stated in the previous page. But now in this case, it means now we'll be needing cos alpha and cos beta. So from this question, we have sin alpha is equals to 5 over 13. We know that sine is equals to opposite of hypotenuse. And this implies that if you have a right angle triangle here, if you have a right angle triangle with that being 90 degrees, if this one hits our alpha, then our opposite will be 5, our hypotenuse will be 13, and our adjacent, we shall obtain the value from Pythagoras theorem. We say that if I can call this one here x, then you're going to have x squared is equals to 13 squared minus 5 squared. So that now you can have x squared is equals to, x squared will be equal to what? So it will be equal to the square, it will be equal to 13 squared, which is 169 minus 25. And so this translates to x squared is equals to, can you be able to compute? What are you getting? What is the value that you're getting? Are you getting 144? So this one is 144. So to get x, simply the square root of 144, meaning that x is equals to 12. So this one is 12. Similarly, also we have sin beta being equal to 40 over 41. So again, you say that this one is the opposite, and this one is the hypotenuse. So if we have the right angle triangle here, if you have the right angle triangle there, and this being our beta, that is our beta, then we shall say that the opposite is 40 and the hypotenuse is 41. So this implies that, again, if you can call this one here y, then you're going to have y squared plus 40 squared is equals to 41 squared. So that y squared is equals to 41 squared minus 40 squared. So y squared is equals to what? So if you try to find out y squared is equals to what? Compute, what do you get? You will get 81. So if you find the square root of 81, you get y is equals to 9. So if y is equals to 9 now, it's now simpler for us to get cos. So we can now say hence here, let's say hence cos alpha will be equal to what? Adjacent of hypotenuse. So meaning that cos alpha is equals to 12 over 13. And similarly, cos beta is equals to 9 over 41. Now, that being the point, our Roman 1, they want us to solve sin alpha minus beta. So the basic thing here is you expand this compound angle formula. And you know this one here will be equal to what? We know that sine alpha minus beta is the same as sine alpha cos beta minus sine beta cos alpha. So, do we have cos alpha as sine alpha? Yes. Our sine alpha is equals to 5/13 times cos beta is equals to 9/41 minus sine beta is equals to 40/41 times cos alpha is equals to 12/13. So we compute this one. You'll get 45. This one you're going to get 5/533. 533 minus 480 over 533. And so therefore, it means that sine alpha minus beta will be equal to 45 minus 485. We shall get negative 435 over 533. That is for sine alpha minus beta. So you can see the basic thing you need just, first of all, to know how to expand. Secondly, you also need to know what do we mean by sine alpha or maybe sine beta. We know that sine is equals to opposite over hypotenuse from the basic trigonometry formula SOHCAHTOA. And so we have to draw the right angle triangles that are going to guide us on how to obtain the one missing side. So we go to Roman 2. Roman 2, we have the compound angle for cos. So we have cos alpha minus beta. So for cos alpha minus beta, we also need again to expand. We have cos alpha minus beta is equals to cos alpha cos beta plus sine alpha sine beta. So again, we have all of them. So we need to substitute. So cos alpha minus beta is equals to, what is cos alpha? Cos alpha, it is 12/13 multiplied by, what is cos beta? Cos beta is 9/41. Then plus, what is sine beta? Sine beta is equals to what? 40/41 multiplied by, the other one is sine beta. What is sine beta? Is this sine beta or sine alpha? That is sine alpha 5/13. So remember this one here. This one is sine alpha. This one here is sine beta. I just interchanged there. So we'll get now our solution being equal to cos alpha minus beta is equals to, when you multiply, if you multiply these two, we shall get what? What are you going to get? Compute. If you take 12/13 times 9/41, you'll be getting 108/533, and then plus If you multiply 40 over 41 times 5 over 13, you'll get 200 over 5, 33. And so therefore, cos alpha minus beta is equals to, if you compute the sum of these two fractions, you'll get 308 over 533. So as we have agreed, you're going to do the rest as your assignment test, whether maybe you've understood the compound angle formulas. So do for sine alpha plus beta, tan alpha minus beta, cos alpha plus beta, tan alpha plus beta. Now, we want to look at, before we go to the half angle formulas, we need to do the double angle formulas. So the next part here, we need to do it is double angle formulas. So let us look at the double angle formulas. Now, for the double angle formula, so we already know the compound angle formulas. And we have said for number one, let's check the double angle formula for sine. So the double angle formula for sine. Now, we already know the compound angle formula. When you speak about the double angle formula, it means an acute angle multiplied by 2. It is twice the acute angle. And in this case, suppose maybe we have the compound angle formula for sine A plus B. We have said is equals to what? Is equals to sine A cos B plus sine B cos A. If A is equals to B, then you're going to have sine B plus B is equals to sine B cos B plus sine B cos B. So if you check now, B plus B, it is what? 2B. So sine 2B is equals to what? Is equals to 2 sine B cos B. Now, if maybe we can talk of maybe B being the theta, as usual, we have been using theta to denote the angle. Then, if B is equals to theta, we simply have what? Sine 2 theta is equals to 2 sine theta cos theta. So, you can be able to see now this one here is the compound angle formula. It is the double angle formula, sorry. This one is the double angle formula. Here is this part here. The double angle formula for sine. Now, is it possible for you to develop a double angle formula for cos? Are you? Okay, fine, good. So what are you going to do? It's all right. So again, the same way you're going to have this approach. You can just have double angle formula. Double angle formula for cosine. Similarly, again, we say we have cos A plus B is equals to cos A cos B minus, remember we said in cos expansion, if this one it is plus, then in between the two breaks is what? Minus. So it will be sine A, sine B. From there, we see that if A is equals to B, again you're going to have cos A, cos B, that is cos B plus B, cos B plus B is equals to cos B minus sin B, sin B. And so if you put the terms together, you shall have cos B, cos 2B is equals to cos squared B minus sin squared B. Okay. So if B is equals to theta, then we have cos 2 theta is equals to cos squared theta minus sin squared theta. So that is the double angle formula for cos. And so it means that we can develop now the double angle formula for what? For tan. So we can have it as, let's say, from double angle formula for sine and cosine, we have tan 2 theta being equal to sine 2 theta over cos 2 theta. This relation when just gets from the basic SOHCAHTOA, that tan theta is equals to cos theta over is equals to sine theta over cos theta. And so therefore, tan 2 theta will similarly be equal to sine 2 theta over cos 2 theta. Now, from there, we know the expression for sine 2 theta. So we're going to have tan 2 theta is equals to sine 2 theta is what? 2 sine theta cos theta over cos 2 theta is equals to cos squared theta minus sine squared theta. Like that. So if I factorize cos squared theta from the denominator, the same way we were the same way we explained for the coupled angle formula, then we shall have tan 2 theta is equals to cos squared theta into bracket. We shall remain with what? 2 sin theta cos theta divided by cos squared theta over cos squared theta into 1 minus sin squared theta over cos squared theta. So what I've done, I factorized cos squared theta from both in the denominator and the numerator. Just the same way I told you, if you have A plus B, we can factorize A to bracket remain with 1, but then plus B over A. So that if I open up this bracket, I'll get here A, and if I open up with this one, I'll get here B. So from that point now, we can simplify that part and that part. So we're going to have tan 2 theta is equals to, so if you check this one cos and one cos will go. So I remain with I'll mean with 2 sin theta over cos theta, and then all this over 1 minus sin squared theta over cos squared theta. So this implies that our answer will be equal to what? Tan 2 theta is equals to 2 tan theta over 1 minus tan squared theta. Why? We know that sin theta over cos theta is what? Tan. And sin squared theta over cos squared theta will be equal to tan squared theta. So this one here is the double angle formula for tan. Now, this one here is going to help us to pursue the next types of formulas, which are the half angle formulas. We couldn't have do the half angle formulas without the double angle formulas. So let us look at the half angle formulas. The half angle formulas. Now, just the same way the name is sounding half angle. So in this case, in this half angle formula, we want to understand that we need to find sin theta over 2, they have an acute angle. Then we also need cos theta over 2, and also sorry, and also tan theta over 2. Now, how are we going to reach up to these points? We only need to remember from the compound angle formula. So we had from the double angle formula, we have sin 2 theta is equals to 2 cos f2 cos what? Not 2. Yeah, it is 2 sin theta cos theta. But then suppose so this one here, suppose now for us to get sin theta over 2. For us to get sin theta over 2, we can expand. We need to expand. We need to expand sin theta over 2 plus theta over 2. Right? So we can get it by this method. But I wanted us to use, so if you can expand this one, you're going to have what? Sin theta over 2 plus theta over 2. This will be equal to what? This one will be equal to, it will be equal to 2, it will be equal to sin theta over 2 cos theta over 2 plus sin theta over 2 cos theta over 2, which is simply equal to what? 2 sin theta over 2 cos theta over 2. And this one, it will be equal to sin theta over 2 plus theta over 2 is sin theta. Now, but I don't want us to use this expression. Let us apply the double angle formula for cos. Let us apply the double angle formula for cos to get another expression for whereby you're going to make sin theta over 2 the subject. So you can say from the double angle formula, from the double angle formula for cosine. We have cos 2 theta is equals to cos squared theta minus sine squared theta. So if we need cos theta over 2 plus theta over 2, this will be equal to cos squared theta over 2 minus sine squared theta over 2. Why? Because here it will become cos theta over 2, cos theta over 2, then minus sin theta over 2, sin theta over 2. So when you multiply, you get cos squared theta over 2 and also sin squared theta over 2. So in this case, it will be what? Cos theta will be equal to cos squared theta over 2 minus sin squared theta over 2. But we know that cos squared theta plus sin squared theta is equals to 1. So this also means that cos squared theta over 2 plus sin squared theta over 2 is equals to 1 still. Because here our angle is theta over 2. So if you can call theta over 2 an A, then we shall have cos squared A plus sin squared A is equals to 1. So from that relation, you can now say that cos squared theta over 2 is equals to what? Is equals to 1 minus sin squared theta over 2. And so we want us to substitute. We substitute. So we can now say, therefore, therefore, we have cos theta is equals to 1 minus sin squared theta over 2 minus sin squared theta over 2. And so this one will lead to what? Cos theta is equals to 1 minus 2 sin squared theta over 2. So make sin theta over 2 subject. So we shall have